Last time we were discussing the relations between the Cartesian and curvilinear positions, and I also gave you a homework problem. Today I'll quickly write down the equations that you are supposed to derive so that when you do it, you will know that you have done it properly. And I will also give you the other form. So, yeah. In the homework, you are supposed to find the equations to go from the curvilinear position to the Cartesian position. Um, so I'll give you the equations for that first, and then I'll give the equation for the alternative one. So here I wrote x, y, z, so I'll write x, y, z in the equations also. So x will be equal to RD plus H plus L plus lambda. Y is equal to RD plus H plus L sin lambda, and Z is equal to so this is what we need to prove. Okay, so these are the equations that will give you the Cartesian XYZ position, ECM XYZ position from the curvilinear latitude, longitude, and height. Okay. Next, by suitable rearrangement of these equations, we can also find the curvilinear position from the Cartesian position. So I'll give you the form for that. There is no need to prove this because once you prove this one, the other form is straightforward. Next is XYZ to latitude, longitude, and height. So longitude is straightforward. 10 lambda is equal to y by x. So from this we can find lambda as k tan 2. K tan 2 is basically 4 quadrant arctangent operation. So that you get the longitude in plus minus within plus minus 180 degrees. And then for latitude and height, we have two alternative representations. The first one is suitable when the user is not near the poles because tan 90 does not exist, right? So when the user is near the poles, we cannot use this form. We need another representation. Okay. Now when the user is near the poles, instead of finding tan L, we find cot L. Just need to reverse the whole thing. This is for the latitude, and then for height, we can see that in the denominator we have cos L in the first representation. We want to avoid cos L near 90 degrees for obvious reasons. Okay. So when the user is not near the pole, so not near the poles, how will you know whether, mathematically, what condition will impose? So generally, when latitude is more than 89.5 degrees, okay, we use this one, and when latitude is less than 89.5 degrees, we use the first representation. Now, if you notice carefully, you see that this L and H, these equations require both L and um, yes, basically this H equation, yeah, both L and tan L and H equation require L and H. So tan L requires H here, and then here also both in the numerator and denominator. H requires L in the denominator. So from the previous equation we got lambda, the longitude, but we did not get latitude. So we need to solve these two equations iteratively together. There are two approaches. Approach one says that you take latitude, longitude and height from the previous time instant, okay, or your previous computation. To use longitude, we can find, we do not require longitude from the previous. Time instant. We need latitude and height. In approach 1, we can use the latitude and height from the previous computation and use them as the initial guess in these two equations. Okay. So to calculate L, we use the previous H, then we calculate L, and then similarly in H equation we use the previous L and we calculate H. Okay, and we can't, then in the next iteration, this is the first iteration. In the next iteration, whatever new values we got, that should be used as the guess. Okay, so this has to be done iteratively until we find that the absolute difference between L new and L old is less than some epsilon, some threshold, okay, predetermined threshold or tolerance we have to give. When this condition is satisfied, then we need to we say that the solutions have converged and we need to stop the expression. So this has to be done for both L and H. It's not necessary that epsilon has to be different. We pick a small value, for example, 1 into 10 to the power minus 4 or minus 5 is the typical tolerance given, but if one wants to achieve higher accuracy, one can give 10 to the power minus 7 also, but sometimes it takes more time to converge when the tolerance is small. So trade-off is to give some value around 10 to the power minus 5. Okay. So this is approach 1. This is possible when you have already calculated L and H previously. But what if you are starting it and you don't have any previous values? In that case, what will you do? In approach 2, we assume the spherical Earth. and find L and H from X, Y and Z. Use this as initial guess. The rest is the same. Only difference is how you are finding the initial guess. Okay, so you use the spherical earth assumption to find the latitude and height from X, Y, Z, and then use that L and H to do the iterations. So if you use the spherical earth assumptions, you will find that latitude and height equations are not coupled. No, they are decoupled. So we can find latitude and height using the spherical earth assumption and use them as initial guess in the iterations. So this is approach 2. Okay. So you need to derive the equations for x, y, z position given latitude, longitude, and height, and then if you rearrange those equations, you will find the other forms. Okay, where you calculate the latitude, longitude, and height using x, y, z. So this is about position. Next, we can also relate the velocity terms, and again I will give this as an exercise to you. I'm not going to solve this now. So this has to be, I'm not going to derive this now. So this has to be done by you. So here we are interested in finding L dot, lambda dot and H dot. Okay. And you need to show that L dot is given by this. Now who will tell me what is this VEBN? V is velocity, okay? Now what are these E, B and N? Who can tell me what it represents? V, E, B, N. So we discuss some conventions that we are going to follow in this class, right? So as per that convention, what does it indicate? V, E, B, N. If V is velocity, it means it is a vector quantity, right? So what is V, E, B, N? You have a test next week. What is V, E, B, N? Nobody has an answer for this. You have marks in class participation. So simply if you attend the classes, that doesn't mean you will get marks. You need to attend as well as participate. Then only you will get marks. Keep this in mind. Who will tell me what is this? If you cannot tell me, then I see no point in progressing further. I mean, you are not following anything, it seems. Shall we stop discussing further? You are not following anything. If you cannot answer this simple question, then I doubt if you are following anything. So nobody can answer this question? Yes or no? At least say no.
Means is it earth center or fixed body frame?
What do you mean by that? You tell me the significance of these letters E, B, and N, and what do they imply in this context?
Ma'am, ma'am, B represents the like body which we are considering
Hmm.
at some height h.
Hmm.
E, e
You should also tell me from their placements what kinds of frames they are. So they represent different frames, and from their placements, there are some particular frames in this context. You need to define what they represent and what kinds of frames they are in this context.
Ma'am, B is the body frame of the body, like the object that we are considering.
Hmm.
N is the NED frame,
Hmm.
and E is the like Earth frame.
What do you mean by art frame? Which art frame you are
Ma'am,
talking about?
ma'am, Earth-centered
Art centered,
frame.
which frame? How many frames did you define in the class that are art centered? Only one frame?
Ma'am, Earth-centered, Earth-fixed frame.
Okay, so you have told us what frames they are, but in this context, they have some different significance, which is evident from their placement. For example, if I interchange B and E, it will not represent the same thing.
Ma-
We do not do
Uh,
that interchange. So why I have put E, B that way? What do they signify from their placements?
Ma'am, it's the relative velocity expressed in the local navigation NED frame.
No relative velocities. If you have not studied it, you will not be able to tell. There is a specific slide in one of the lectures which clearly tells what this representation signifies. That was discussed in the class. So if you do not follow or understand that, I'm not telling you only, okay? I'm
Ma'am,
telling
it's
you.
the lean.
Hmm.
Ma'am, it's the linear velocity of the frame, body frame with respect to the Earth frame and along the axis of NED frame.
Art centered art fixed frame, okay? Simply if you say art frame,
Yes. Yes.
that is not sufficient because we have defined two frames, earth-centered inertial frame and earth-centered earth-fixed frame. Both are earth-centered frames. Okay. So it is
Yes.
the linear velocity. V represents linear velocity of the body frame, meaning the velocity of the origin of the body frame. With respect to the ECF frame, earth-centered earth-fixed frame, E is the notation for ECF frame, resolved along the axis of the NED frame, local navigation frame. Instead of and if I write E, it does not represent the same thing. In that case, E is also the resolving frame. So the convention is important. What notation we are following, that is important. Otherwise, you will be actually having a different velocity vector. I mean, the representation will be different. Any question? Are you not following things? Let me ask you one thing. This simple question could not be answered. The PhD students also could not. They are actually not following anything. They are simply present in the class. So you need to prove this. Okay, so this has to be proved. This is a homework problem. I already gave you some homework problems in the previous 2 weeks, and in the tutorial class tomorrow you are expected to explain them. This will contribute to your class participation marks. 20 marks have been reserved for class attendance, participation, and for the project. So simply attending classes just by being physically present is not sufficient. In fact, if somebody is physically present, if somebody is not physically present, he will not get any marks. That is fine. But if somebody is physically present but do not understand anything, do not follow anything, and do not also participate in the class discussion, he will also not get any marks, even though he is present. Because he is physically present but actually is not following anything. Keep this in mind. Do you have any questions? Because I don't see proceeding further this way. You do not follow anything and I'll keep on talking. What is the point of doing that? If you have any question, ask me. So if something is not clear to you, you are not following something, ask me. I know there are people who can't even define vernal equinox, although this was discussed in the class. So what is the point in proceeding this way? So if there is some problem, if you are not able to follow what I am saying, if I am going fast, tell me. I really do not want to keep on going this way when you are not following things. Let me know if you have any problem or anything that you are not actually getting. I'm discussing what you are not getting. Let me know. There is no problem. Everything is fine, but still you are not able to answer questions. This is what I should understand. I should assume. If you tell me the truth, this is not going to affect your marks in any way, okay? Are you following or not following? No response. Are you following or not following?
following, ma'am.
You can't even define vernal equinox. So how do you say that you are following? Ajita, what is the problem? Tell me.
I mean,
Hmm.
I'm following the in the sense I have solved the problems what you have given in the last class about the Doppler frequency and all. That is fine. In the recent classes, like I mean, last two classes, like I have watched the recorded video again, but still I have to go through some reference book or something. For that, I am not finding. I mean, I did not find in this time in this week, so I'll go through it. To I mean, today evening. Or in the weekend, ma'am. I mean, this week it was not possible for me to follow. I mean, I'm listening to you, ma'am, but still I have
Okay.
to go through all those ones.
Okay, that is fine. But is there any problem with the lectures?
No, ma'am, it is good. I mean, it is fine for me at least. It is okay.
Okay, next we are going to talk about attitude. See, this is a small class, okay? And I do not want this to be a monologue. I'll keep talking and you will not follow. And if I ask any question, you just go blank. This is not how uh, things should go, okay? So you should also participate in the discussion, and you can participate only when we follow things and you also study. Otherwise, you will not be able to follow anything. This class, everything in this class is going to be new for you from A to Z. Not a single term, unless you have done something before, will be known to you. So unless you put in extra efforts, it is very difficult to follow things. Again, and once you lose track, you will just lose it unless you put in extra efforts. So next we are going to discuss attitude. You already noted that attitude means the orientation. Of one frame with respect to the other. There are different ways to represent attitude. In this class, we are going to talk about four methods at a high level. They are Euler angles, this is also called Euler attitude. Then coordinate transformation matrix. You probably call it the direction cosine matrix. Same. In navigation, we call coordinate transformation matrix. In quaternions, and finally rotation vector. Now we are going to discuss the first two methods in somewhat more detail. Next two Wattonians and rotation vectors we will just define and will not spend much time. And attitude is required only if we talk about the INS, Inertial Navigation System. As far as GNS is concerned, in this class we do not require attitude. But it is worth knowing, in case you do not know about this method, it's worth knowing how we represent attitude. Okay. So let's start with the Euler angles. So Euler angles are a set of rotations, set of 3 rotations What about each of the 3 axes, orthogonal axes at a time. So we need to apply 3 successive rotations, and each rotation should be about one of the 3 orthogonal axes. Okay, it's not that we apply rotations about all the 3 axes simultaneously. It's a set of 3 rotations, 3 successive rotations. And there are different sequences that can be followed in navigation. We generally prefer the 3 to 1 sequence. Okay. So, and using these 3 sets of rotations, we can orient any frame with the other. So suppose we are interested in finding the orientation of alpha frame with respect to some other beta frame. So let's say this is the beta frame and this one is the alpha frame. Okay. So in this case, beta is the reference frame and alpha is the frame of interest. We want to find the orientation of the alpha frame with respect to the beta frame. So what we need to do, we need to apply a set of rotations from beta frame to go to the alpha frame. 3 rotations. Okay. Since we are following the 3 to 1 sequence, I'll give the rotations accordingly. So let's call this XYZ axis of the beta frame. In the 3 to 1 sequence, we first apply the rotation about the Z axis. This rotation is called yaw rotation. How do you define positive rotation? We curl the fingers of the right hand about the axis of interest. In this case, it is Z axis. Okay, such that the thumb points along the positive axis. So if you point the thumb along the positive Z axis and curl the other fingers around the axis, the direction of the curl will tell you the direction of the positive rotation. So you just orient the fingers of your right hand this way so that the thumb is along the positive Z axis and you curl around the axis with the other fingers, and the direction of the curl will give you the direction of the positive rotation. The arrow that I have shown is actually the direction of the curl. So this is positive rotation. So after applying this rotation, and the corresponding angle is denoted as psi. Okay, after applying this rotation, psi rotation, the Z frame, because we are applying the rotation about the Z frame, the Z axis, the axis is not changed. Z axis is not changed. Only X and Y are changed. So this is the new orientation of X and Y. Z remains the same as before. This is the first intermediate frame. Next, in the 3 to 1 sequence, the next rotation that we will apply is about the y-axis. Okay, and again using the method that I just told you, you can find the direction of positive rotation. So this rotation is called pitch, and the corresponding angle that we use in this class is theta. To apply pitch rotation about the y-axis, and since the rotation is applied about the y-axis, y-axis remains unchanged, only z and x will change their orientations. So y-axis remains unchanged. The rotation was this way. This was the previous z-axis, and this was the previous x-axis. Mu z and mu x. We call this z double prime and x double prime. This is the second intermediate frame. The next rotation that we will apply is about the x double prime axis. Again, it is the positive rotation. This. And the corresponding angle is phi. Okay, this is called roll. Okay, after applying the roll rotation, this time x-axis will not change its orientation. The x will remain the same as before. Dash lines represent the previous orientation. This angle is phi. This is also phi. And this one is theta. So theta. Psi. Okay, so these are the three rotations that we apply one at a time to go from the initial frame to the final frame. So after applying suitable rotations, we can align the beta frame with the alpha frame. Okay, and the Euler attitude is denoted as this bold psi. Okay, so this psi is different from the yaw angle. That's why it is shown as bold psi. And we are going from beta frame to alpha frame. So we are interested in representing the attitude of the alpha frame with respect to the beta frame. This is why beta is written first and then alpha is written. So this is the attitude or orientation of the alpha frame with respect to the beta frame. And it is having three angles. Okay. And we go from bottom to top. So the first rotation is the psi rotation. We are following 3 to 1 sequence. So the first rotation is written at the bottom, psi, and then theta. The next one was pitch rotation and then roll. So if you write the angles in this manner, it does not indicate that first roll was applied, then theta, then psi. It does not. Rather, psi was applied first, then theta, and then phi. So we go in this direction. This was the first rotation applied, this was the second one, and this was the third rotation. Psi, theta, and phi. This is why we say 3 to 1 sequence. So as per 3 to 1 sequence, first is the yaw rotation, then pitch rotation, and then roll rotation. Okay. Now the order of rotation is important. Okay. The order of rotation is important. So if you write phi, theta, and psi, and then theta, phi, and psi, you will not get the same alpha frame. Even though we start with the same initial frame, beta frame, by changing the order of rotation, you will not get the same resulting frame. So order of rotation is important here. Then there is, in the 3 to 1 sequence, there is a singularity at plus minus 90 degrees pitch. What does it mean? See, the pitch rotation is applied about this y prime axis, right? You just apply 90 degrees rotation, pitch rotation about the y prime axis. Then what will happen? The x axis after the rotation will become parallel to z prime axis or z axis, correct? Are we following? When I
Yes,
say
ma'am.
that 90 degrees pitch rotation about the y prime axis will make the x prime axis parallel to z or z prime, right? Similarly, the new z axis after the rotation will become parallel to x, correct? The next rotation is about the x prime axis. Now with 90 degrees pitch, x prime has actually become parallel to this one, correct? And you will apply the rotation about that axis. So basically roll and yaw become indistinguishable because the new x prime axis is parallel to z axis. You already applied the yaw rotation about that z axis, and again you are going to apply the roll rotation about an axis parallel to z axis. So you are losing 1 degree of freedom. Okay. This is why we say that there is a singularity at 90 degrees plus minus pitch. Then roll and yaw become indistinguishable. Okay, so you're basically doing the roll rotation about an axis about which is parallel to the axis about which you already applied the yaw rotation, right? Now this phi, theta, and psi. So this means first we apply psi, then theta, then phi. So we are going in this direction. This set, okay, and this one, phi plus phi, pi minus theta, and psi plus pi. These two sets, they give the identical alpha frame, and we do not want that. We do not want two different sets giving the same resulting frame. Okay. So in order to avoid this, the following condition is imposed. Okay. Theta must be within plus minus 90 degrees. Just see, when we impose this condition, what happens? In one of the sets, theta must be greater than 90 degrees, and that set will be eliminated by imposing these conditions. Okay, so in order to have two different sets giving the same alpha frame, in order to prevent having two different sets giving the same alpha frame, we impose these conditions. Okay. Now this is the Euler attitude from beta frame to alpha frame. Since we are going from beta to alpha, we can put beta alpha in the angles also. How about psi alpha to beta? When we write psi alpha to beta, it means we are interested in going from alpha frame to beta frame. Then we are interested in finding the attitude or orientation of the beta frame with respect to alpha frame. Now if you think that this is equal to minus of the angles, then this is not correct. So just by reversing the angles, you cannot go back to the beta frame. Either you need to reverse the sequence, first you apply psi, then theta, then phi to go from beta frame to alpha frame. So to go back to beta frame, you need to apply first phi, then theta, then psi in the reverse direction. That means psi alpha beta should be minus phi, then minus theta, and then minus psi. And this is not a 3-to-1 sequence because you are not having first your rotation, then pitch, then roll. Instead you have phi, roll rotation, then pitch, then roll. You are just reversing the sequence to go back to the beta frame. So this is one way. And if you want to stick to the 3-to-1 sequence, then you need to find the angles, corresponding angles, and that you can write as psi alpha beta, theta alpha beta, and phi alpha beta. And this is not equal to minus phi beta alpha minus theta beta alpha minus psi beta alpha, not equal to. Okay, the order of rotation is important. It's not that simply if you change the order and you will get the original frame. That's not the case. You need to either reverse the order and keep the same angle. The magnitude should be the same, reverse the order, or you need to find a different 3-to-1 sequence to go back to the beta frame. Okay. Now suppose this is the Euler attitude from alpha to from beta to alpha frame, and this is the Euler attitude from alpha to gamma frame. So don't think that the Euler attitude beta to gamma is given by this. Don't think that. So they do not add. The rotations are not additive. So Euler rotations are not additive. So this is the Euler attitude or Euler rotation from beta to alpha. Then this is the Euler attitude from alpha to gamma. So simply by adding them, you will not get the Euler rotation from beta to gamma. So rotations are not additive. Euler rotations are not additive. Okay. Now suppose you have been given the Euler attitude of the alpha frame, which is the body frame, the frame attached to the body, vehicle body, with respect to some reference frame beta at some point in time. So you have the Euler attitude of the alpha frame with respect to beta frame at some point in time t. What if the alpha frame is changing its orientation? It's not necessary that at t plus 1 or at some other time t1 you will have the same Euler attitude. If the alpha frame is changing orientation or beta is changing orientation, you will not get the same Euler attitude, right? So how will you find the Euler attitude at some other points in time? So for this purpose you need to propagate the Euler angles, correct? You can propagate the Euler angles only if you find the derivatives, right? So to find the Euler attitude or Euler angles at different points in time, you need to use their derivatives. So next we are going to derive the equations for the time derivatives of the Euler angles. You are interested in finding phi dot, then theta dot, and then psi dot. Okay, as a function of phi, theta, and psi, and alpha is the body frame, beta is the reference frame, omega is the angular velocity. So omega is the angular velocity of the alpha frame with respect to beta frame resolved along the axis of alpha frame. Using an inertial navigation system, we can measure the angular velocity with respect to the inertial frame. Okay, and then with the help of mathematical computations, we can find the angular velocities with respect to some beta frame, which need not be an inertial frame. Okay, and we can also resolve the components of the angular velocity along the axis of any third frame. In this case, we have picked the alpha frame. So we can find this omega vector from navigation sensors. And we know phi, theta, and psi from the previous computation. So at t naught we know, or at t we know phi, theta, psi, and we are interested in finding these angles at let's say t plus 1. So using their values at t and the measured the computed angular velocities omega, we want to find the derivatives of time derivatives of phi, theta, and psi. Okay, tomorrow we'll do that, and then we'll also do few other things. We'll note the advantages and disadvantages of Euler angles, and then move on to the coordinate transformation matrix. There also we'll discuss few properties of coordinate transformation matrix, and then Uh, Still, if we have time remaining in the first class, we will talk about quaternions and rotation vectors. In the second class, I want to discuss the tutorial problems, okay, the homework problems that I had given, because you have a test next Friday and the syllabus is up to whatever we cover till next Wednesday. Okay, so whatever we are discussing now, everything including the tutorial tomorrow will be included in the test. And the syllabus is up to Wednesday's class, next Wednesday's class. Okay, that's it. Any question?